This video is about common terms and relationships of circles. Following is a list of circle terms and relationships. A chord is a line segment with endpoints on the circle. So these would be the endpoints. This line is the chord. A secant is a line that intersects a circle at 2 points. This line is a secant and it intersects the circle at this point and this point. A tangent is a line with only one point in common with the circle. So this line is tangent to the circle because it really only intersects the circle at one point right in here. An inscribed angle is an angle with vertex on the circle and sides that are chords. So here, this angle has its vertex here on the circle, and then its sides are chords. Remember, chord is a line with endpoints on the circle. So these are 2 chords. It's the sides of the angles, and here's the vertex, which is on the circle. A central angle is an angle with vertex at the center of the circle and sides that are radii of the circle. So these are lines that are actually the same as the radius of the circle, and this vertex of this angle is at the center, hence it's a central angle. The intercepted arc of a circle is the part of a circle between 2 sides of an inscribed or central angle. So this right here is the intercepted arc because it's the part of the circle that lies between the 2 sides of the central angle. Going back to this inscribed angle here, this part would be an intercepted arc because it's the part of the circle that's between the sides of the inscribed angle. The degree measure of a central angle is equal to the degree measure of its intercepted arc. So this degree measure of this intercepted arc is the same as the degree measure of the central angle. A equals B. The degree measure of an inscribed angle is equal to half the degree measure of its intercepted arc. So here we have an inscribed angle with vertex on the circle and sides that are chords. And what this says is that this degree measure C of this inscribed angle is equal to half the degree measure of this intercepted arc of the inscribed angle. So C equals half times D, half of D. The degree measure of an angle formed by 2 intersecting chords is equal to half the sum of the angle's intercepted arcs. Okay, so here we have 2 intersecting chords of a circle. And then what this is saying is the degree measure of an angle, right here, this is an angle formed by the intersection, this is an angle formed by the intersection. This degree measure of an angle, like this one, is equal to half the sum of the degree measures of these 2 intercepted arcs here, of these angles. So here's the intercepted arc of this angle, the intercepted arc of this angle. So half of the sum of these angles, half of the sum equals this angle here. Example 1. Find the measure of the question mark angle. So we want to know what's the measure of this angle here in this circle. Given that this degree measure of this intercepted arc is 120 and the degree measure of this intercepted arc is 155. Since this angle where we have the question mark is a central angle because its vertex is at the center of the circle and its sides are the radii of the circle, and since the intercepted arc of the central angle has degree measure 120, we know from one of the previous relationships that this central angle would be equal to the degree measure of the intercepted arc. So the angle is 120 degrees. Example 2. Find the measure of the question mark angle. Since the question mark angle is formed by 2 intersecting chords, and the degree measures of these intercepted arcs of the angles formed by the intersecting chords are given, we know from one of the previous formulas that the angle measure question mark would be equal to half the sum of the degree measures of these intercepted arcs. So we just plug it in to the formula, simplify to get that this angle is 114 degrees. Following is a list of additional chord and tangent relationships of circles. Statement 1. The chord of a circle is bisected by a diameter that is perpendicular to the chord. So here's the chord of a circle, and it's saying that this length is bisected by this diameter. So then this divides this length in half. The second statement is that a line segment from the center of a circle to a point of tangency is perpendicular to the tangent. So it's saying that if you have a line that's tangent to the circle and there's a line segment drawn from there, that point of tangency, to the center, then this is a perpendicular, it forms a perpendicular angle here between this line segment and this line that's tangent to the circle. This is a perpendicular, and you can see with the picture it does look like it would be perpendicular, right? Perpendicular is a right angle. This does look like it would be a right angle. Statement 3. The line segment drawn from the center of a circle, so this line segment here, where two equal tangents meet. So these are lines that are tangent to the circle, so they're tangent lines. So if this line segment is drawn from the center to where these two tangent lines meet, this line bisects the angle formed by the tangent. So this angle is bisected by this line that goes to the center of the circle. So it divides this angle in half. We're going to use these three statements for example 3. Example 3 says, find the measure of angle 1. We want to know what is this angle if we have these two lines that are tangent to the circle, these line segments that are the radius of the circle, and we know that this angle here is 160 degrees. What is this angle? There's multiple ways we could find it. We're going to use the three statements from above. Step 1. By statement 3, if we drew a line from the center of the circle to this point where these tangent lines meet, then we'd be dividing this angle 1 in half. It also bisects the angle here. It bisects this angle here of 160, so we divide it in half to get 80 degrees on each side. So that gives us actually a triangle. If we drew a line here, we'd have a triangle where this angle here is 80 degrees. So here's that triangle. Here's angle A, here's half of angle B because we bisected it with that line segment we drew to where the tangent lines meet. And here this angle is 80 degrees. By statement 2, this angle A is a right angle. So this is 90 degrees because this is a line segment drawn from the center to the tangent line. This is perpendicular, which means this is 90 degrees. So that's by statement 2. So now we have a triangle where this is 90 degrees. We have a right triangle where this is 90 degrees. This is 80 degrees. This is some unknown angle, but it's half of the angle we want to find. Then on step 3, we have, since the sum of the angles of a triangle is 180 degrees, the sum of these three angles would be 180. 90 plus 80 plus half of angle B would be 180 degrees. So we can set this up as an equation, solve for B, which was angle 1, to find what is angle 1, which, solving this, subtract 80 from 180, subtract 90 from 180 because angle A was a right angle, then multiply by 2 to get that angle 1 or angle B equals 20 degrees. There is actually another way to solve this. Maybe you could see, if you want a challenge, what other way you can approach this problem to find angle 1 using geometry.